Welcome to the Triangle Theorems video. So this podcast is going to be more about some big ideas rather than solving. You'll be asked more about big ideas on the benchmark. So D is the midpoint of BA and E is the midpoint of BC. Which of the following must be true? Well, we know if it goes from midpoint to midpoint, it's a midsegment. Right? And we know some things about midsegments. We know that the midsegment is parallel to the opposite side. So we know DE is going to be parallel to AC. We also know that DE, the midsegment, is equal to half the opposite side, or you can think of it the other way. You can think of two midsegments. That's a weird looking E. Two midsegments equals one opposite side. So any of these, any and all of these are true. All right, so let's go through the answer choices here. AC is half the length of DE. Well, that's not right. It's DE is half the length of AC, the other way around. Something happened to my equal sign. I think the lines didn't line up. So this is false, right? That's false. DE is perpendicular to AC. Well, they're not perpendicular, right? That's false. AC is parallel to DE. That is a true statement. DE is a third of the length of AC. No, that 1/3, that's medians. Right, so a median, if we have the midpoint to centroid, that's a third, but a median goes from the vertex to the midpoint, not midpoint to midpoint. So this is false. DE is half the length of AC. Well, that's true, right? AC is twice as big as DE. DE is half the length of AC. So these are the true statements, right? So those two are true. The other three are false, right? And that's the big idea about medians. Let's look at the big idea for midsegments. Which of the following relationships is true? Let's go through all the true things. Because sometimes when you're reading them, it's easy to get things kind of confused. And when you figure it out yourself, it's a little bit easier. Right? So we have the three medians. Right? So the medians are FB, CX, and AE. Right? They go from the midpoint to the vertex, right? So these are the three, let's see if I can do this straight. These are the three medians. And the medians are divided in a certain way, right? So we know that vertex to centroid, let me move this over just a little bit so I have space to write, equals 2/3 the median. We know the midpoint to centroid equals 1/3 the median. Squeeze that in there. We know that the midpoint to centroid equals half the vertex to centroid. Or we can go the other way around. We could say the vertex to centroid is 2 times midpoint to centroid, right? And we know that these are all midpoints, and the midpoints are going to divide the sides into two congruent segments. So we know that's all true. All right, so now let's use all of that information and figure out which ones of these is true and which ones are false. AD, all right, so AD, this is, not right in red, this is vertex to centroid. Right there, vertex to centroid, there's the centroid, equals 2DE. Well, DE is midpoint to centroid. And if we look at our list, vertex to centroid is 2 times midpoint to centroid. I'm just going to erase that one. So right now we're just using the one where I put the black asterisk. So that is, this one is true. All right, let's try the next one. Try to write in a different color. I got a lot of colors up here already. BD is half of DF. All right, so BD is vertex to centroid equals half of DF. Well, DF is midpoint to centroid. Oh, but that's not right. This part here, that's not half of DF. It's the other way around. It's twice DF, or DF is half of BD. It would be correct to say DF is 1/2 BD, but it's wrong the way it's listed here. Let's try the next one. So we were still using the same one. CX equals 2CD. So CX, that's the whole median. And CD is vertex to centroid. Well, vertex to centroid is 2/3 the median. So this is false. All right, let's try the next one. AD is 1/2 AE. So AD is vertex to centroid. And AE is the median. So we're still using this one here, but the vertex to centroid isn't half the median, it's 2/3 of the median. Right? That centroid doesn't cut that line in half. I mean, you can look at that and see that's not half. Right? That's wrong. And it really is, and sometimes our diagrams are just diagrams. When we construct the centroid, it really is 1/3 and 2/3. Right? So that really is in the right spot. Let's look at the last one. XB is half of AB. So XB is so I don't have it listed down there, but I marked it on the whole thing there. So XB is so X is the midpoint. Let's write it that way. X is the midpoint of AB. And what's it going to do? It divides the segment in half. Right? Notice that AX is congruent to XB, and AX is half of AB, and XB is half of AB. So this is also true. There were 2 true statements here. And I didn't say there was only one. This one had 2. All right, so make sure you know your relationships, and you can use that to help you out. So this here we looked at the relationships of medians, right, and how they're divided. So we looked at mid-segments, we looked at medians. We're going to look at exterior angle. And this one actually combines base angle theorem and exterior angle theorem. For how long that topic is and all the things that you could learn, we get one question. So we're just going to focus we're just going to look at the one question. What is the measure of angle DCE and angle DCA? So we're going to find, so DCE is right here. let's find that angle first. I think that angle would be easiest. Now let's think, this is an equilateral triangle. We learned with base angle theorem that angles opposite congruent sides in a triangle are congruent. We also learned from triangle sum theorem angles in a triangle add to 180 degrees. Right? So if all three sides are congruent, that means all three angles are congruent. So x plus x plus x equals 180 degrees. Well, x plus x is just 3x. And if we divide both sides by 3, x is 60 degrees. Well, these two are vertical angles, and we know that they are always congruent. So angle DCE is equal to 60 degrees. And you could solve this angle here technically in about 3 different ways, this angle here. You could solve it using exterior angle theorem. Right, so using exterior angle theorem, angle DCA is equal to angle A plus angle B. Well, if this angle x is 60, all the x's are 60, so that means angle DCA equals 60 plus 60, or 120 degrees. That's one way you could solve for angle DCA. Another way you could solve is using a linear pair. And so we know this angle is 60. Angle DCA plus, there we go, angle DCE. I don't think I'm able to fit it there. I'll just put it down here. Equals 180 degrees. If we subtract 60 from both sides, angle DCA is equal to 120 degrees. Right? We could also find it, it's also a linear pair with the angle DCE as well. Oops, well, that's the one I ended up using, but that's okay. I could have used the other angle, angle ACB. So either way, whether I use this angle or this angle, it's a linear pair. I was thinking of using the one where it says x equals 60, but it doesn't matter since they're both the same measure. And it's a linear pair with both of them. So here's a couple different ways to solve this problem. Remember, base angle theorem tells you that angles opposite congruent sides in a triangle are congruent, and it does work the other way. Remember that the angles in a triangle add to 180. Right? And then remember exterior angle theorem that, and as a reminder, exterior angle theorem, I'll move this down a little bit so I can write. The exterior angle equals the sum of the two remote interior angles. Right? So two different ways, technically three, but two main ways to solve for that angle there, angle DCA. All right? So we've got a lot of information on this problem. Reviewed a bunch of things, a bunch of concepts related to geometry and triangles. I think this is the last one on this video. Yep. Next videos are a little bit shorter. All right, so if you remember, we did this proof when we were proving base angle theorem. Let's see if you can remember the missing steps. All right, so it's a good idea to start with the given. AB is congruent to AC, and right up on top there under the words given. And then AD is the angle bisector of BAC, also given. Because AD is the angle bisector, we know that angle BAD has to be congruent to CAD, because that's what an angle bisector does. Divides an angle into two congruent angles. We were proving the triangle, and actually we had this much up here so far. We're proving the triangle's congruent. We would need another side, and then we could be able to solve, prove the triangle's congruent here using side angle side. And I see that I know AD is congruent to AD. And why is AD congruent to AD? Well, hopefully you remember that that is the reflexive property. And then what triangles do we prove congruent using side angle side? Well, our two triangles there, we want to match them up. We'll match up the corresponding parts. So I'm going to call it angle B, or triangle BAD. So if I call it triangle BAD, angle B goes with angle C, angle A goes with angle A, and angle D goes with angle D. And we have, oops, that's supposed to be a triangle, sorry. And we have written the triangle congruent statement. All right, so you will see this proof. All right, just a little reminder there. Just remember some of your theorems and definitions when you're solving proofs. All right, remember your congruence postulates especially. All right, and remember reflexive property, vertical angles. Right, you'll be seeing those throughout the benchmark. All right, and this course. All right, thanks for watching. Bye for now.